Good morning, everyone. So, welcome to my YouTube channel, Math Satra. So, today we are going to see 10th lecture on infinite series. Today we will study root test. This is also one of the important tests to check the convergency of a series. Okay, series with the non-negative terms. Okay, or you can say positive terms. Ratio test. Let summation n goes to 1 to infinity a n be any series, and suppose that limit n tending to infinity and nth root of absolute value of nth term a n is equal to rho. Then first a the series converges absolutely if rho is less than 1. B, the series diverges if rho value is greater than 1 or rho is infinite. Okay. And third case is C is the test is inconclusive if rho value is 1. So let's see its proof, how it works. First, rho is given that rho is less than 1. Now choose an epsilon greater than 0 such that rho plus epsilon is still less than 1. It is possible. Okay, we can choose epsilon greater than 0. That this happens. Since limit n tending to infinity is equal to rho, there exists capital M belongs to n such that this happens. So how can we write this part? So how we can write this part? This implies rho minus epsilon. Now taking this much part. So this implies. Okay. So solve it. What we will get? We will get this one. Now, now this series sum n goes to capital M to infinity. Rho plus epsilon to the power n is a geometric series with common ratio, common ratio rho plus epsilon that is strictly less than 1. Therefore, this series is convergent. By comparison test part first, the series summation n goes to m to infinity an is also convergent. From which it follows that summation n goes to 1 to infinity absolute an that is a1 absolute plus a2 absolute is convergent. Because adding finite numbers of terms in a series does not change the convergency of series. If some series is convergent, it will remain convergent. Or if some series is divergent, it will remain divergent. Therefore, this series n goes to 1 to infinity an is absolutely convergent. So this part is done. Now, B part or second part, rho is in this range. It can be infinity and it is greater than. Then, now choose epsilon greater than 0 such that such that such that rho minus epsilon is also greater than 1. Since limit n tending to infinity is equal to rho, there exists capital N belongs to N such that minus rho less than epsilon. So this implies rho minus epsilon is less than. So taking this much part, but this is greater than 1. But this is greater than 1 because of choice of epsilon and rho is greater than 1. We choose epsilon greater than 0 such that rho minus epsilon is greater than 1. So, so this implies taking nth root nth power, taking n power both the sides. So it can be each term is greater than 1. So this implies this cannot tends to 0. Okay. This implies an does not tends to 0 as n tending to infinity. Hence, or therefore, therefore, the series summation n goes to 1 to infinity an diverges. Now, C part, rho is equal to 1. Take this series summation n goes to 1 to infinity 1 upon n and n goes to 1 to infinity 1 upon n square. So for this series, what we have, what is this? This is equal to, what is this? So this implies limit and tending to infinity. What is its limit? It is limited limit and tending to infinity. But this is actually one. The limit of this is always one, so this is one. For this series, so this will be also okay. In both the cases, rho is one, but the series summation n goes to 1 to 51 upon n is divergent, and the series sigma summation is absolutely convergent, and hence convergent. Therefore, for rho is equal to 1, the test is inconclusive. Inconclusive means it can be convergent, it can be divergent. Okay, in the case of rho is coming 1, okay, we cannot conclude anything. So this theorem is done. Now we see some examples. Example 1. So an is this. An is equal to n upon 2 to the power n. If n is odd, 1 upon 2 to the power n. If n is even. Thus, this series converges solution. So what is this? I can write this. So what will be this? N to the power 1 upon n by 2. If n is odd, and it will be 1 upon 2 if n is even. So this implies in both the cases. So actually what is this implies? If you take n is equal to 1, it will be 1 by 2. Then it will be increased. It means these terms cannot exceed this part, and the minimum value is 1 by 2 for all. Okay. Now, what is limit? Limit n tending to infinity, 1 by 2 is 1 by 2, because this is a sequence, constant sequence. That is also limit n tending to infinity, because this limit is 1 by 2, both the limit. Now we can apply sandwich theorem. The sequence is infinite. We can apply by sandwich theorem. By sandwich theorem, we get what is the limit of this sequence? Limit n tending to infinity. That is also 1 by 2. That is less than 1. Since rho is equal to 1 by 2, that is less than 1, we conclude by a root test that the series summation an is convergent. Yes, is convergent. Okay. So this is done. This is absolutely convergent. So it is convergent. Because the terms of series is non-negative. Absolutely convergent means it is convergent. Because absolute will be same term. Because sequence of sequence an is non-negative. It means positive. Now example 2. This series n square 2 to the power n. So what is an is equal to n square 2 to the power n. So this implies n square 2 to the power n. So this implies. So what is this? So what is the limit? Limit n tending to infinity. That is also 1 by 2. Okay. Since rho is 1 by 2, that is less than 1. We get by ratio test, sorry, root test, the series the series is convergent. Now example 3. Summation n goes to 1 to infinity 2 to the power n upon n cube. So what is this? An is this 2 to the power n cube. So this will imply. So this implies what is the limit? Okay, that is rho. That is rho. And they said 2 is greater than 1. So this implies by root test, by root test, the series summation n goes to 1 to infinity 2 to the power n cube is convergent. Sorry, is divergent. By root test, it is divergent. Sorry, because value is greater than rho is greater than 1, so it is divergent. So now C part, for example, 4 summation n goes to 1 to infinity 1 1 plus 1 1 plus n to the whole power n. So an is equal to 1. So this implies, okay, so this implies limit limit that is 0. Okay, since rho is equal to 0, that is less than 1, we conclude that the given series summation n goes to 1 to infinity 1 upon 1 plus n to the n is convergent by root test. So today's lecture up to this. If you have any problem related to this, you can comment on YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.